Thank you for visiting. This video will describe a hardware solution to microplastic detection that does not use Nile Red staining or fluorescence. Macroplastics are present in the environment as domestic and industrial waste. Microplastics are present as millimeter or submillimeter fragments of macroplastic parents or as manufactured submillimeter particles. We know the polymer of parent plastics by their recycle icon. Detecting submillimeter ecologically dangerous microplastics is not so easy. At present, the standard method to detect microplastics is to stain samples with Nile Red, followed by an examination in fluorescence. However, the Nile Red protocol is problematic. Nile Red is not specific to plastics, it also stains oils, fats, lipids. It requires noxious chemicals such as chloroform, acetone, or methanol. Stained samples must be incubated from 30 minutes to hours. Realistically, the Nile Red protocol is a laboratory-intensive method. The challenges associated with Nile Red demand an alternative approach. With over 25 years' experience designing and producing custom hyperspectral imaging systems, Lightform developed an inexpensive instrumental solution called ColSpec. ColSpec is a hardware solution designed to detect microplastics from 2 micron to millimeters. It is field portable, inexpensive, requires no chemicals, or no sample incubation. ColSpec acquires a field of view in less than 100 milliseconds. It is not difficult to run an average of 80 sample fields per hour, with minimal sample preparation. Produces high signal-to-noise high-contrast images. It is non-destructive, samples can still be submitted to alternate testing. Key hardware elements of the system include high numerical aperture optical zoom magnification, with many available options. CadFly illumination provides intense 40,000 lumen, critical angle dark field illumination. Detects transparent or colored particles as small as 2 micron. Reveals morphological detail. Size and shape aids in identification. And detects glitter. Bright field illumination reflects light from all objects back to the camera, resulting in low contrast images. Transparent polyethylene, almost disappears on white paper. CadFly is an acronym for Critical Angle Dark Field Light Illumination, resulting in an absence of specular reflection from smooth surfaces, and produces a dark or black background. The ColSpec system consists of a color camera, a zoom lens and CadFly illumination. CadFly delivers higher contrast imaging than bright field reflection. Depending on the mode of bright field illumination, transparent polyethylene can seem to disappear entirely from the field of view. The following sample images include abraded submillimeter domestic plastics, 280 micron tip-to-tip glitter, sometimes added to provide a size reference for other objects. Glitter is a true manufactured microplastic. It is ubiquitous and almost indestructible. Glitter ranges in size from about 50 micron to millimeters. Glitter has been manufactured in bulk for over 60 years. Every glitter particle ever made can still be found in the environment, including landfills, rivers, lakes, oceans, especially in our homes and offices. The example microplastic images that follow were acquired under the following conditions. Acquisition time, 100 milliseconds. Magnification, 1.2x. Field size, 1920 by 1080 pixels. Microplastic examples in CadFly illumination. The first image is polypropylene, then high-density polyethylene, then polyvinyl chloride plumbing pipe, and finally a ground-up polystyrene tray. Custom ColSpec software controls the camera, performs object classification of target objects, creates classified object libraries and recognition, determines class abundance and displays the results in histogram and pie chart formats, and measures the size of particles. In this example, a field of diverse microplastics have been automatically classified, and the abundance of those classes shown in histogram and pie chart formats. Look for a detailed description of the ColSpec software in an upcoming video. Is ColSpec an infallible way to detect microplastics? Absolutely not. But the hardware enables a rapid, non-destructive way to assess candidate particles with a high degree of specificity. Is ColSpec better or worse than Nile Red and fluorescence? It is better. Dark field reflectance produces high signal-to-noise, high-contrast images. All fluorescence emissions are significantly weaker than white light dark field reflectance. Do I need ColSpec software to make ColSpec work? No. But when microplastics are in the presence of clutter solids, the software can unselect those solids that do not classify as plastic. How robust are reference color spectroplastic libraries? Within a series of samples, very robust. It is easy to determine if a library is not performing to expectations. If you have questions or comments, please do not hesitate to contact Team Lightform.